Okay, a quick video for two of you guys who are working on these extra problems. Isa, you did pretty well on them, but you made a couple of errors. This first problem, xy minus e to the xy equals 7. You're going to differentiate this implicitly. The derivative of xy, you have to use the product rule. And remember, whenever I'm differentiating, I have x times dy dx plus y times 1. That's the derivative of this, minus the derivative of e to the xy is e to the xy, but then I have to multiply by the chain rule. The derivative of this, which is x times dy dx plus y, equals 0. Common mistake is to leave that as 7. Then I do a bunch of algebra, collecting the terms with the dy dx's, and I end up with this. Now the other one, sine inverse x dx. The only way to do that is by parts. You did it pretty well, but u equals sine inverse of x, dv equals 1 dx. So du would be 1 over root 1 minus x squared dx. You have to have those trig inverse derivatives down to a science. So v equals x. So this integral equals uv minus the integral of v du. Then you look at this, and you properly said I could do this by substitution. U equals 1 minus x squared. Du equals negative 2x dx. So negative 1/2 du equals x dx. So I could rewrite this integral as negative 1/2 du over u to the 1/2. The integral of that is not ln of u to the 1/2. Bring this u to the 1/2 up. You get u to the negative 1/2 du, add 1 to the exponent and divide by it. So you should end up with, after everything out, x sine inverse of x plus root 1 minus x squared plus c. So last point, the only time say I'm doing the integral of 1 over, I didn't even write it right, 1 over x plus 2 dx. The integral of that is ln of x plus 2 plus c. I have x being linear down here with a constant. As soon as I have an x to the 1/2 or an x cubed or whatever, I cannot do ln of it. All right, hope that helps. See you tomorrow.